And in fact, there are two of them, and they were discovered a few years after the receptors. They're called anandamide and 2-AG, or 2-arachidonyl glycerol. And these are the endocannabinoids, the natural THC-like compounds. So THC only works because it speeds up, increases the rate of what's already going on. And so what already going on is this cannabinoid signaling. So what is that doing? Well, in the brain, there's neurons, as you know, and typically the neurons receive input around their soma or their cell body, and they conduct it electrically. This is sort of the code of the nervous system down their axons. And then the axons branch usually, and there's a little gap between the axons of one cell and the soma of the next cell. And that gap is a synapse, and 98% of drugs work by affecting the synapse. So we looked there for THC's effect, and to describe that, I kind of blew this up, the synapse up. So normally what happens is neurotransmitters are released from the end of one neuron to act across the synapse to the next cell. And that next cell has receptors like dopamine receptors or acetylcholine receptors or serotonin receptors. In the case of cannabinoids, the communication goes in the opposite direction. This was a really novel mechanism for people to try to understand. So here is the cell, it releases the neurotransmitter. Maybe that neurotransmitter is glutamate or GABA or another neurotransmitter. Those neurotransmitters interact on this cell across the synapse. And then these little C's are cannabinoid molecules. So anandamide or 2-AG that get released and go back and talk to the first cell. This was a really new mechanism, and as I said, it's in practically every synapse. So what does this mean? I have a picture of my dog to help explain that, my cute dog, because I think I can illustrate it good with him. So what this indicates is that some message comes across a synapse, and then the endocannabinoids are synthesized and released to go back and sort of send a message, sort of a bidirectional message across the synapse. And that, we think, acts like a highlighter to say the message that just came through was something really important, was something salient. And the reason it's all over the brain is because you never know which synapses are going to be transmitting important or critical information. So this helps us decide what to learn and how to learn, and it helps us sort important information from not important information. So Bowden, one day, my dog, was out in the yard as a puppy. Actually, he was about this age, and my daughter dropped a piece of bacon in the grass. And you can bet that was important for the dog. That was like a big day. And so what I would say to illustrate this is that his brain, he found the bacon, and as he did, his olfactory system got turned on, his motor system got turned on, his learning and memory. Wow, this is great. What is it? And so anandamide probably got released in many structures, in many circuits, to tell Bowden, okay, something really great just happened. Something really meaningful happened. And he knows that. He still goes back to the same spot. It's never happened again. And that would be the case for us too. I don't know what your bacon is, but maybe it's a great idea you have, or it could be bacon, it could be chocolate, it could be a first kiss or something. But when those events happen, the idea is that anandamide would get released from the postsynaptic side to go back and say, aha, mark this. This is critical. And that plays a role in forming long-term memories. So that's how anandamide and 2-AG work. But what about THC? Remember, those receptors are everywhere.
Does someone you love suffer from drug addiction? accidental drug overdoses are the #1 cause of unnatural deaths. Don't wait until it's too late. Call our 24/7 helpline at 1-800-648-6734. A caring addiction specialist is awaiting your call.